Okay, let's dive right into this explainer. Today, we're looking at something that recently dropped from Deepseek, and honestly, it's easily one of the most fascinating infrastructure releases we've seen all year. It's called Deepseek. Now, if you're immediately thinking, great, just another massive model drop, hold that thought for a second. What Deepseek has done here is actually far more clever than just throwing a mountain of compute at training a new model from scratch. What they've given us is a total masterclass in efficiency. The absolute crucial point to understand right out of the gate is the Deepseek is not a new model. It is a brilliant bolt-on engine upgrade. They took their flagship Deepseek V4 Pro, which as we know is already an absolute powerhouse at 1.6 trillion parameters with a mixture of experts architecture, and they attached this hyper-smart speculative decoding module right on top of it. The model itself didn't get any smarter, it has the exact same intelligence, but the way it generates text just got dramatically faster, with way less waiting time for you and me.
Which brings us to Section 1.
The one-token bottleneck.
To really appreciate why Deepseek is such a massive game changer, we have to look at the underlying traffic jam that happens inside these huge models. When an LLM writes your code or answers a question, it does it one token at a time. A token is, well, roughly a word or a piece of a word. But here's the crazy part. Generating just one single token requires a full, wildly expensive computation pass. We're talking about billions of parameters lighting up just to spit out one tiny chunk of text. And then, it has to do it all over again for the next token, and the next. It's incredibly thorough, sure, but man is it slow.
Now, the theoretical fix for this has been kicking around the research world for a bit, and it's called speculative decoding. The core idea is simple, but really elegant. Instead of forcing the massive, expensive model to write every single word from scratch, you bring in a small, super fast, cheap draft model. This little draft model races ahead, just making rapid-fire guesses about what the upcoming text will be. Then the large model sweeps in right behind it, acting kind of like a senior editor to verify those guesses. And the best part? The final output is mathematically guaranteed to be identical to what the big model would have written on its own. Literally zero quality loss.
Moving right along to Section 2, smarter, faster draft guesses.
So while speculative decoding sounds absolutely perfect on paper, it historically had a major weakness during that guessing phase. Older speculative decoders generate all their draft tokens at the exact same instant, completely blind to one another. Think about the phrase, of course. If a draft model tries to guess the first and second words simultaneously without communicating, the first token might correctly guess of, but the second token is just guessing blind. It might output problem, leaving you with the nonsense phrase of problem. The further ahead the model guesses, the worse these blind errors get, a phenomenon researchers call suffix decay. Well, Deepseek fixes this beautifully by introducing a sequential head. They keep that fast parallel backbone, but add a lightweight module that lets draft tokens peek at what their immediate neighbors just decided. Instead of guessing blind, the neighbors talk. This one tiny change is so effective that Deepseek actually beats previous best methods by about 30% in accepted token length.
That leads us right into Section 3, managing the compute traffic. Now, verification from that massive big model isn't free. If 5,000 users hit the API at the exact same time, the whole system can completely clog up. So Deepseek introduces confidence-based scheduling to act like an ultra-efficient traffic cop. First, those draft tokens are generated. Second, the system assigns a confidence score, estimating how likely that specific guess is to actually survive the big model's verification. And finally, it watches the real-time GPU load, only pushing through the tokens it's highly confident in to totally prevent the hardware from getting overwhelmed.
So, what happens when you fix both the guessing blindness and the verification traffic jam? Deepseek achieves something pretty incredible. Out in the real world, in production on real user traffic, Deepseek delivers 60 to 85% faster generation per user compared to their old setup. It's simultaneously handling more speed per user and vastly more users at the exact same time.
Let's look at Section 4, real-world performance examples.
When we break down the data, it's clear that not every single type of prompt benefits equally from speculative decoding. And seeing how it performs really helps us understand how the engine thinks. Code generation, for instance, sees massive gains naturally because the vocabulary of code is highly predictable. The draft model makes great guesses, and the scheduler easily verifies those long sequences, making coding agents lightning fast. Math reasoning sits kind of in the middle. While it handles stable, long logic blocks exceptionally well, the sheer complexity of advanced math introduces just a bit more variance into the draft guesses.
But the most shocking result, and honestly the most important for everyday applications, is in open-ended chat.
Chat is notoriously hard to predict because human conversation can go in a million different directions. Before Deepseek, speculative draft acceptance for chat hovered around a pretty underwhelming 46%. But by utilizing Deepseek's smart sequential head and that confidence threshold we talked about, that acceptance rate skyrocketed to nearly 96%. If you're out there building conversational AI, customer support bots, or real-time voice assistants at scale, this is the metric that literally changes your business overnight.
And finally, Section 5, the open source ripple effect. Beyond Deepseek's own servers, this breakthrough has massive implications for the whole AI ecosystem. Speculative decoding has been a super promising research concept for a while, but what Deepseek does is definitively prove that it works in the trenches. It proves you can push these massive speed gains into real production, serving at global scale. And true to form, Deepseek didn't lock this technology away behind a corporate vault. They entirely open-sourced their recipe under the highly permissive MIT license. They released the paper, the training code, and the model weights. And their repository doesn't just include Deepseek, it actually includes implementations of DLash and Eagle 3 as well. This means any open model team anywhere in the world can study these leading speculative decoding approaches, benchmark them against each other on their own hardware, and adapt them for their own models.
By just giving away the blueprint for generating 60 to 85% faster outputs with zero quality loss, Deepseek has effectively lowered the compute barrier for everyone. Because this release proves that these massive speed gains actually work in real production at scale, it leaves us with one incredibly exciting question. With the Deepseek recipe now entirely open source, what is the AI community going to build next? Think about that, and I'll catch you in the next explainer.